think the last question was quite pertinent, so I'll probably take from there because we suffer kind of the same problems that you do. And I relate to a lot of the stuff that you said because in his case it's screws, in mine it is minimum bolts and nuts, which are M10 and M16. So pretty much the current state of traditional industry, and I do believe that I'm from traditional industry, which is manufacturing. This is probably the only day I'm in a full shirt. So most of the time I'm on a half shirt and uniform. So I was just commenting in the morning saying that I was here at 8 in the morning. So I said, you can take me out of the factory, but you can't take the factory out of me. So I'm here at 8 in the morning. So pretty much the first problem that we have is none of this is from any textbook. It's just my experiences with AI for a couple of things. Data is king for even the simplest machine learning problems. So to answer your questions, we are probably not going to share it with anyone because we don't know what's there in it for us. What if you made more money than what we could do with it? So we're not going to give it to you easily, unless we know for sure that we are protecting what we own and we don't know what we have. Now, this leads to extreme protection and what I call brown data. This is like shit that's stored for ages and we really don't know what to do. It's rusting out there and nobody's using it. And probably if somebody decides to mine it, we will have lots of use for it. I'm sorry for this scatological reference, but that's fine. The point is that there's tons of data in most of our enterprise systems. It's there in different forms. We were running systems on IBM 390s, flat files, and we still have those test data there. And yet, when a frontliner, which is my third point, a frontliner needs data, he creates a new truck and he runs it on a test track for 50 kilometers. And we probably have tons of such information coming from telematics devices. Terabytes of data that's coming in from telematics devices. So the first thing is that these are three critical issues. One is that we have tons of data sitting in an ERP systems. Second, we have disparate systems that don't talk to each other. Other than being transactionally linked, most of our systems talk only on a need-to-know basis. So whether it's our dealer management systems or our CRM systems talking to our ERP systems, talking to our PLM systems and our design systems, they talk on a need-to-know basis. So for example, I have lots of actual in-use application data, which is residing in my CRM and telematics information systems. And yet, when a test engineer wants to do engineering, it's a struggle for him to get our own data. And it's extremely painful, not because it's not just, as most people say, it's evil intent of other functions to not share information. It's usually not evil intent. It's just that they don't know how to share terabytes of data. If my email could send you a 10 MB Excel file, I'm comfortable sending it to you. But if I have to send you 300 flat files of 1 million records each, I really don't know how to share this with you. And I have that data. And all of us have seen the classic blind monkeys versus Swedish students video. I see those moments all the time with engineering. I see engineering has a view of usage conditions, which is probably 8 to 10 years from where it is today. And they design systems for those use cases. And then we realize that when we launch those products, they are used completely differently. And it's only because they didn't realize that they had that information. And if they'd looked at it, they would have designed it differently. To give you a classic example, a truck on an average runs 6,000 kilometers to 8,000 kilometers a month. Now this information is used for reliability, it's used for engine testing, it's used for vehicle proving, it's used for tons of stuff. and accelerated testing. Now, we've got information over the last 3-4 years that thanks to GST, better roads, for example, today in Tamil Nadu, you can't get a bad road to simulate. Somebody was talking about road simulations and getting, I think one of my classmates was talking about it. You can't get a bad road. We had that information. The 6,000 to 8,000 had already gone from 8,000 to 10,000. Now that's a 33% to 20% shift, depending on which applications you look at, 20 to 33% shift. And this is a significant move in terms of the warranty expectations, life expectations, is payback period for that. And this has to go into engineering. And because our systems don't talk to each other, it never went in. Leave alone do simulations to say what we do with it. So the first challenge that I think is that we need to overcome this. Now, I don't have answers because we have not practiced these. But these are my possible solutions. We don't have answers. Now, when I have a problem with my laptop in my computer, in my office, we have a help desk. I ask the help desk for data, for correcting my hard disk, for something that I need on network. We have infrastructure as a service. But we don't have query as a service. We really don't have query as a service. I'm an engineer who designs clutch. I want to know how much applications are happening on one of my best-selling models. I need to be able to query a big data system and get this data. Slice and dice it in different way, run queries on it differently and explore it before I feed it into machine learning or an AI algorithm. Now the first part takes up so much of my effort that I stop doing this. I say, okay, let me instrument a brand new test vehicle. The second thing is, there are not every engineer, while they would have worked on MATLAB and they would have worked on a lot of simulation, not every engineer is capable of prototyping his initial AI system to even prove the concept. In fact, a lot of the partners that we look out for, that's the support that we probably need. And we don't need it as firm contracts. I'm a great believer that given the fluidity in this industry, we need this as a service. Mine is probably a big budget program, but there are tons of engineers who don't have budgets that are big. But they have small and nice problems that they would like to give out, and there's only 20% probability that they're going to be successful. Now, if anybody operates a service for this kind of thing and partakes some of this risk, that's a good model for most of them. So tools that prototype AI. The third thing is funding for data collection and transmission. Like Professor was saying, I don't know what goldmine rests in it, and therefore I'm not going to share it. Traditional industry has another problem. Every sensor costs money on the basic vehicle. Every sensor generates information that needs to be transmitted back to the OEM, and that costs money. Now, while there is hype, leadership will fund it. And the first business cycle of downturn, we will stop funding all data transmission and data collection. So, this funding for data collection and transmission is probably a very critical need, and that needs to be understood. I have lived through, like he has said, the same age-old two generations. I wrote a paper sitting here in IIT Madras with a professor, Sukhendu Das, and my last paragraph was, we would like to use failure with artificial neural networks, but we don't have the compute power to do that. This was the actual, one of the conclusion points, saying that this is the next step in this paper that we are publishing. So I think the big thing is going to be how do we ensure funding and continued interest in this topic. There is one thing that we always need to keep in mind is the human-machine interfaces. And I'm talking not just the way we talk to a system, but how is it integrated into our physical processes. For example, out of the 6 projects that we did, only 1 is in production. And it's in production in a way in which the users don't know about it. My dealer sales executive who are making sales calls don't know that the list of probable customers that they are meeting are generated from an AI system. So it's mixed into their regular beat plans. The remaining 4 or 5 projects that I personally mentored are all complete failures, except for being used as validation by people when they are in doubt. When they think that their emotion is taking control of their senses and they want some kind of a validation to say, is my forecasting right? Is my prediction right? Or my boss told me this cannot be the way. So he wants to check it and prove his boss wrong. Those are probably what I consider as failures of AI. But it still meets the purpose, because once in a while those people come back to me and say, hey, can you run that system up? Can you up the system for me once more so I can run a prediction model of it? So this integration and creating new empowered roles is probably something that we are looking forward to in traditional industry. Thank you. I extended by 4 minutes, I think. Yeah.
Thank you, Karthik. Since I am also part of a startup, I have some thoughts on the POC, but not for here, but we will talk about that later. Let me call Ranga, who's with Honeywell, who's into trying AI in solutions, to give his views on.
Good afternoon, everyone. So I'm going to eat into your lunchtime, but we'll make it short. See, my belief is slightly different here in the sense that Honeywell, for example, the division I belong to, look at these as the important wheels for us to make money. I belong to a division called Safety and Productivity Solution, where we predominantly look at the safety of the workers. So we make a lot of these equipments that are shown along the worker. And the productivity, we have a lot of productivity tools that both digitize and also help them in their operations around the workflow that's defined for different processes. And the last one is about the preventive maintenance, in the different industries that are part of our portfolio. Now, if you look at all these 3 things, we have been applying, as Professor Raghu was saying, for a very long time, data analytics, fault diagnosis, or you can call in different terminologies, equipment health monitoring. This has been there for the last 20, 25 years within the Honeywell business pages itself. We've been offering as solutions, either remote, cloud, on-prem, whatever way you want to call. Right, but then what is that is transforming now? What is that our group is trying to do, given that it has so much baggage of 20, 25 years? That's what my view I want to put here. So ultimately, what they want to do is improve the throughput. And say if you take a warehouse, it operates at 2% margin. Now, if I'm able to increase it even by 0.5%, that's a whole lot for the warehouse. So everybody starts looking at how would I improve, continuously improve, right? Some of these things, while I don't compromise on the safety, as well as I make sure that the employee, is not taxed for working harder, right? So when I look at, I'll give you a couple of examples, before I go into what my thought process is. Right. So here, if you see here, I have put 2 diagrams. One is a valve. A valve can malfunction, say in a refinery, it can lead to some downtime. Think about, what do we measure as data for valve? There are only like 2 variables. the percentage valve position and the flow measurement that goes through. But then using these data, if you see, this topic has been researched for nearly 25 years. I was a PhD student of Professor Raghu who have researched this 15 years ago. Even now, papers are getting released. 15 years before, also papers were getting released. Only on those 2 data points again. Now, you look at it, researchers across, across the globe, whether it's Japan or Israel or Bangladesh, everybody has published. But then they work on these 2 data, bring out so many features or metrics and their own methodologies. It could be a spectral method, it could be an FFT, it could be a time series, area, whatever you want to call, right? So everybody has a perspective to solve that problem. And so that's one part. And the second part is the motor bearing fault. So again, I took this example because it's been there for 40, 50 years. Again, you see the amount of data variables that they constitute to solve the problem, very few. But then the number of techniques that exist today, you go and do Google, you will see like millions and millions of articles. And then on these 3 data points, they will have multiple metrics. Now what it says, interestingly, if you look at from a time series point of view, right, across domains, whether it's financial or weather data or any kind of economics data, everything is around time series. And then people have researched on this, and then recently somebody has published a paper where they said there are about like 7,800 features that you can derive out of time series, which includes some of the metrics that I talked about, valve, bearing, all those fields, right? So what does it say basically is that, right, if we give a platform for people to get these features on their data, they don't know which features are important, but I come from a viewpoint that our group is good in hypothesizing the problem statement and probably the data associated with in validating that hypothesis, right? So we are good in these 2 as engineers. What we are not good, if you see, is the tools that needs to be solved, right? So we lack that tool to go and do ourselves. Excel used to be one form of tool. Now, if you extend Excel to say that I generate all these metrics for you, that is around solving different domains problem, correct? And then somebody gives me that and then say, okay, for these metrics, these are the valuable metrics out of this for your problem statement. And then he goes and solves them. And then he finds a solution to his problem statement, whether he's an engineer working in TVS motors or in a supervisor sitting in a warehouse and trying to look at the data. They are the closest. They don't need to share data with anyone. They have to do the first proof of concept that I have an hypothesis, I have data, I have to figure out a way to solve. If I go and look out for vendors, if I go and look out for taking out data, putting it in Excel and then putting that initial effort of getting the data that are relevant, it may not be too big an effort if they can solve it locally, just using with their domain knowledge, but the tool itself is handy enough for them to solve that first portion. There is a lot of steps to be carried out to validate this, but at least that's the first step that we need to provide, empower. So every engineer, whether he's sitting in an industry, warehouse, or in some other place, aerospace, if he's given that empowerment to validate his POC, then there are lots of steps that needs to go where vendors and other people can validate in a larger data set, integrate with their systems, make it real-time, productive, and all that. So that requires a different engine altogether. I think what we are lacking is this part of the engine where empowering the engineers, where they have their own hypothesis and then validating with a tool that they don't need to come up with new features and think about solving problem rather than hypothesize that I feel these data, with this data I'll be able to do this and try it out. So this is what I think, in my view. I have gone through this personally. I have changed domain. I have hypothesized. I have felt this route is more fruitful. I may not be able to give the solution put into production, but at least I would go back to the management and say, this is a problem statement. This has this much value, and this is how it can be solved. Yeah, thanks.
Well, if that's possible, it would be great. We come to the final presentation of the day. Rajneesh will, again, from automotive industry, will give his perspectives on AI in engineering.
So, good afternoon. May I know how many material scientists are here, sitting here, or designers? And thank you. And designers? All right. All engineers, I suppose? All right, brilliant. So, to begin with, I would like to also ask, to make it a little bit interactive, I know it's an afternoon session, but can anybody tell me what's that picture on the bottom right? Otherwise, I will have to answer that. Sorry? Top view of a staircase. All right, interesting, yes. Processor, cool. All right, great. This is related to engineering and the future of engineering, which we all are facing. And when we look from the perspective of the big data, and this is the kind of words, but this is something which I'll touch upon in the end, what it is, and that's the actual future of scientific computing. All right, to begin with, that's why I made the title of the talk, A Peep into the Future. That's the peep. I'll bring it into that. So to begin my talk, so I would like to have a quick, I'm from Rolls-Royce, and most of the time there's a misconception that Rolls-Royce, which car, I'm in Phantom or like that. So I would like to just briefly mention that. So Rolls-Royce, just have that the commonality between the Rolls-Royce PLC and the cars business is only the brand name. Rest all we have sold to BMW with the license rights. So this is a brief glimpse of what Rolls-Royce is having after the transformation in 2019 and 18. Last year, these are the three main businesses: civil aerospace, defense, and power systems, and the two functions. And I belong to R-Square Data Labs to begin with. And so I'll be talking most of the time in this talk on the civil aerospace domain. The very reason is that I belong there and work on that in the defense as well as in the civil, but more than 50% of the revenue is coming from the civil, and there are reasons for that. I'll touch briefly on it. So this is a brief description of that, what are the three core businesses, and we're trying to link, I will try to link that into the AI for engineering in the next slide. So if you see that, one of the key things that there has been an investment from Rolls-Royce consistently of the order of more than £1 billion every year. And definitely, I mean, on the bottom right corner, you can see that that number is talking about the investments in the UTCs. That is the University Technology Centers. We have 31 across the world. And how much investment in the PhDs and research staff in the academia or in the other research laboratories Rolls-Royce invest in from the engineering perspective, being a technology company. Coming to the AI for engineering, so how many of us are from the thermodynamics background here or gas turbines? Brilliant. So I have a colleague here at least. So cool. So I'll take a quick glance and then would like to draw your attention towards what I titled this talk as the challenges and opportunities in engineering. If you see that on the left-hand side of this particular slide, we have the TET on the y-axis. That's turbine entry temperature. So in a typical gas turbine, in the jet engines, so after the combustion chamber and before the high-pressure turbine, so the temperature which is faced by the high-pressure turbine blades is the turbine entry temperature. And turbines are the prime movers for the gas turbines. They run the system. They draw the energy from the flow. So if you see that, on the x-axis, I have years listed. And these all are Rolls-Royce engines. And from 1940s till almost 2000s, when Rolls-Royce started developing, and already now they are in the service, the Trent series, Trent 700, 1000, and likewise. So if you see that the turbine entry temperature has increased almost 800 degrees Celsius, big number. It is not a small number. Material scientists, that's why I asked that, how many material scientists are sitting here? The AI for engineering, what are the opportunities? At the same time, we have achieved it together as an engineering community, but at the same time, you see that there are challenges. Now, how many materials can withstand this temperature? Really, very few. And on the right-hand side of this graph, you can see that. So titanium, which is one of the strongest, the specific strength perspective, and specific is the key term we use in aerospace. So now here, the density of the nickel is almost double than the titanium. But if you see that, so when we are talking about these temperature zones, titanium doesn't hold good. So we need to, although it's contrary, it's a kind of a trade-off. We need to look into that. all the aerospace vehicles need to be lightweight because we want to fly high, and weight is definitely not a positive thing we would like to carry with us other than fuel and passengers. So the point is that here, now the key challenge we need to face is that where are the materials which can withstand this temperature? So what I say that an opportunity which we bring in with this particular understanding of the advancements in the technology is that which type of materials and we can bring into our space so that we can start exploring different dimensions using AI. And finding a new material is not a cakewalk. I mean, the professor can add to that. So it's really, really tricky. Now, I'm just talking about here, I have not drawn the actual active research which is going on today. So this is nickel-based superalloys where turbines are made of. I'll show you the turbine blade very soon in the next slide. And the current state-of-the-art research where AI can build and help, and it is already going on, is cobalt-based superalloys. So these all kind of challenges and opportunities we need to appreciate and see that from where, whatever there is in the hypothesis and the modeling which we need to draw, there are millions of combinations. So, but still, we can do that computationally quickly rather than going with the holy grail of experiments every time. So in this particular slide, you can see that, so I'm just trying to connect the dots between the turbine blade, which I was earlier mentioning as a prime mover for the gas turbine. And on the left side, you see a turbine blade which is which one person is holding. It's so tiny, turbine blade, this much, so powerful. And you'll be amazed that this particular turbine blade has the CF, centrifugal loading, which is like one particular bus, fully loaded bus is hanging at the edge of that blade. This tiny blade, which is you can hold in this hand. So these many CF loading is there because of the speeds at the more than 16,000 RPMs it is rotating. And the temperature it has to withstand is approximately of around 1,500 degree and more, which is more than the melting temperature of this particular metal, nickel-based superalloys. These are the challenges for the engineering. So how to come up with solutions? So there are multitude of opportunities where AI can bring in. So one of them would be like for the CFD people, computational fluid dynamics guys. So and computational combustion dynamics colleagues. So if you see that there are certain holes over here, these small. Where's my mouse? Yeah, these small tiny holes. So these are cooling holes. And the CFD people can start understanding, and they have already kind of mastered this. These particular profiles of these holes are very critical. We take the air, we call it bleed air, from the IP, intermediate pressure compressors, and then send this air, which is relatively cooler, 800 degrees Celsius, 400 to 800 degrees Celsius, and then ensure that the blade can operate without melting. So those all types of things AI can bring in to understand that what should be the gas flow path and what should be the topology of these holes. And there is very huge amount of trick is involved because the engine has to fly over deserted areas and salty environments, and which leads to sulfidation and oxidation. And chemistry is very complex for that. And oxidation and sulfidation do happen with every engine. And those particulate matters, when it flies through the deserts, is even more finer sometimes. And then it can clog these holes. Then what happens? That. Within minutes, it melts. And there are fatalities because of this in the literature. So what I'm trying to offer in this particular slide is that if you see that from the turbine itself, there's a huge amount of computational analysis we can do quickly by trying to do different level of permutations and combinations in the design to understand and bring, which AI can offer to us. Then in the middle, this particular cartoon is towards that gas turbine engine design is a complex exercise in itself. It takes around half a decade at least when we say that, okay, this is a new NPI, new product introduction. So from that perspective, so there's a huge amount of scope because there are different type of multidisciplinary optimization we need to bring in. And optimization is one of the key thing I see when we say that, most of the times, I hope my co-panelists will also agree, we always talk about this term AI, but I disagree with that. We are not working on AI. I'm not working on AI. I'm working on MI, machine intelligence. I'm not working on AI. That's why people start, getting confused that, oh my God, I mean, this is AI and, you are not building very smart systems. No, we are trying to make machines intelligent. We are not trying to build, or rather, I'm not trying to build a machine which is like human. I'm trying to make the machine intelligent where it is tending towards that, but not the objective of which is generally known as AGI or general intelligence. So when we start appreciating that, then the questions which earlier we were trying to adhere or kind of address from the audiences was that, it's over-promised. Let's understand that what are the opportunities. So on the right-hand side, extreme right, so these are the couple of things which Rolls-Royce is already working on from the AI and engineering perspective, and there are also opportunities. For example, in the top, so when we do an X-ray for a human being, when there's a bone fracture, I don't want that you should have that, but still, I mean, some way or the other, we have experienced it, right, in the hospitals or likewise. So imagine something which is rotating at 16,000 RPM. If you do an X-ray, how do you find it? When you do an X-ray for a human being, they say like, please stay still, please stay still. I'm doing an X-ray of you. Imagine something rotating at 16,000 RPM and you perform an X-ray. How do you figure it out what's happening? So Rolls-Royce has mastered that, and we use the image processing and defect detection, identification, and positioning techniques for that. And there are lots of literature available, so I encourage if any of you would like to understand further, so please go through that. So the second one is the design optimization. So AI, or rather what I call MI, is more towards that very smart way of mathematical optimization. My postdoc was in applied mathematics, so that's why I can correlate it. It's a very smart way of optimization. When we start appreciating the applied mathematics behind that, we are in very good shape, and we can make solutions towards the engineering problems rather than just glorifying it. So then we have model-based system engineering and AI. When we start combining, then there are a plethora of solutions we can start building up for these engineering problems. The third one is, which my co-panelists have also touched upon, is EHM, engine health monitoring, or also known as equipment health monitoring, and prognostics and diagnostics, which I'm also personally involved in algorithm developments for remaining useful life of an engine. An engine, gas turbine engine generally have a lifespan of approximately 30 to 40 years, so the scale is in decades. Now, and it generally goes through shop visits for the complete overhaul and strip for an engine is approximately 3 to 4. And Rolls-Royce generally lease, or in general companies lease engines, and we get money by flying by hour. So from that perspective, if we can reduce the shop visit, one shop visit, huge amount of saving of money, and we ensure that there's no disruption for the airliners, for the customer. So in that perspective, prognostics, predictive, when something is going to fail with a high level of accuracy is very critical, and definitely fault analysis like diagnostics. And I touched upon CFD and CCD. We are also using machine learning and AI-based techniques for NDT, non-destructive techniques, because this is one of the certification norms that we need to blow off the blade in the operational engine to ensure that the whole passengers are safe, the flight is safe, when there is a this kind of catastrophic, relatively mishappening can happen, and it do happen at times. And definitely on a material level research, so AI can help in speeding it up, so by finding out the right material and at the right pace. And then the last one on this particular slide is towards on the VR, virtual reality, augmented reality, and the mixed reality to interact with the intricate spaces and to give an access to the people. Like recently, there has been a tie-up with Rolls-Royce and one of the airliners where it has been given an access to understand. So I'll skip this, I got cues. So this is the last slide, which I would like to end with that. What is the future looks like? Before I answer that, what was there on the bottom right part in that first slide. So recently there has been a collaboration between Rolls-Royce, among Rolls-Royce, University of Nottingham, and Harvard University, where we started and demonstrated something known as a FLAIR project, where it's affectionately known as snake robots. And like an endoscopy, I mean, we have a kind of 4 millimeter to 3 millimeter bore area where boroscope has to go in and do the inspection. So now these snake robots will make a swarm and try to also do a patchwork, especially to make certain kind of repairs in a cohesive way. So that kind of demonstration is the future where we all are heading towards, and AI is the backbone for that. Or I must say that mathematics is the backbone for that. So yeah, this is very much, this is it from my slides. This is something which I love, and this is the future of scientific computing. On the bottom right, you see a quantum chip. This is a quantum computer from D-Wave. It's a company in Canada, and they have commercialized it. This is a D-Wave 2000. So this is not a fault-tolerant quantum computer, please remember that. But this is a 2,000 qubits, 2 raised to power 2,000. It will take lifetime to write down that number in a computer as well. So with that, I will end my talk. So if there is any particular questions, we can connect after that. Thank you for it.
I think we have come to the almost end of this panel. We have about 15 minutes of time left till 1:30. So if you have any pressing questions till 1, how many of you have questions? Just let's quickly take 2, 3, 4. We'll take these 4 questions and give short answers because 5 questions if possible. And I actually want to ask all of them one question for which I need a very short answer. So I'll keep 5 minutes or 10 minutes for that. So we have about 10 minutes. We can go over by 5 minutes. So if we can have these questions asked.
Hi, my name is Vinayak. I am the CTO of Zoomcar. So I see a lot of automotive panelists, including Ford, who is an investor. So I just wanted to quickly talk about a couple of problems we're facing and possible solutions. So one of the problems that we're working on is predictive maintenance. I think someone from Honeywell also kind of touched upon that. And also the data that is input for predictive maintenance, one of the things that is needed is the CAN data, right? The challenge with the CAN data is CAN is a standard, as many people know, to get telematic data out of the engine through the OBD port, the onboard diagnostic port. But there are specific codes for each OEM that the OEM doesn't easily give away. And that is a huge problem, right? And because those are not standardized, because every engine is different, every car is different. But for consumers of those vehicles, for example, our company, Zoomcar, that's a huge problem. The other thing which somebody mentioned about brown data is we also would like to know something about the road condition and elevation data. So there's a lot of telematic data collected through trucks, through vehicles, and there is this data available in silos, right? So today if I want a map of India with this kind of data overlaid, there isn't one place where I can even buy this data or go to any OEM and do this, etc. So one of the things that I feel that India lacks, and I know there has to be cooperation and competition, similar to what you have in other places also. For example, if you look at the OEM vendors in the router space, there are the Huawei's, Juniper's, Cisco's of the world that compete on equipment, but they also work on standardizing certain parts. But I feel that is like the missing piece that is kind of holding us back with respect to that. So I just wanted to know the panelists' thought on, is there any possibility of co-innovation and licensing that data, and basically standardize some of the standards, especially in the automotive space, because it's a good representation of automotive engineers here. Because this is a real problem that we're trying to solve, but it's not happening because of the lack of good data sets.
Your first point on the CAN data, see, whatever is regulatory is standard. J1939, I think, is the standard. That's pretty much standard, and we share that data. Anything beyond that which we require for refinement, we typically don't share it. None of the OEMs share it. There are people who can hack it for you, but that's fine.
Yeah, we end up reverse engineering
I know.
that. Yeah.
There are tons of guys, and I'm sure none of the others will say, but all of us do that. So for our benchmarking trials, so I think that's not the way to go. I agree with you that the regulatory norm itself needs to be expanded to include a few more parameters that would be useful as public data. In terms of the kind of data sets and sharing those data sets for preventive maintenance, etc. Almost all OEMs have about a quarter of their revenue coming from spares and service revenues. I am not sure if anybody is going to give that away by sharing this data on preventive maintenance. It's almost anathema, and that's where most of the OEMs make money. Selling the base equipment, you don't make much money. So it's the service that makes you a lot of money. So given that, one of the primary business cases for funding data collection for themselves is preventive maintenance revenues.
Which is where the part I talked about co-innovation, right? Like this data that we collect, like there's several thousand kilometers that we do more than 1 lakh trips. We are happy. So many times I've had this conversation with OEMs.
Sometime if you get time, please read a Wired article. I think it was by, which is the tractor guy? US.
Yeah, John Deere. John Deere.
Who owns the data? So technically your OEM is, Ford has given you a Zoom car, a vehicle on a lifelong lease. Which is what John Deere called it. So the data belongs to Ford. Yeah, sorry.
Hi, good afternoon. This is Lakshmi Vaidishwaran. I'm from Gyan Data, and we are service providers in the AI area for manufacturing companies. So the question, I basically wanted to share some of our experiences here. Working with manufacturing companies, we are plagued with this big issue about dirty data coming to us. So the amount of effort it takes for us to do the forensics before we really get started, before we have done the basic mass energy balance and got some sanity in the data to do future work. Industry on the other side is waiting for results to get delivered in 1 month, 2 months, 3 months is too long a wait. So that's a problem that we have faced with industry. Second is the amount of time it takes to translate an idea into an actual project. We've seen 4 years of discussions finally materializing. My question to the panelists was, what has industry done to fast track processes, fast track or set expectations at a level which are promoting companies like us to provide services in differentiated areas. So we are not in the commodities AI business. We do customized solutions. But penetrating into industries, getting the expectations right is what we have struggled with. And I wanted to see the amount of flexibility or the change that industry is facing is addressing to work with partner companies in areas like this.
So I think 2 things. One is, oftentimes this is something which is nice to have. And especially for pharma companies, these things are important, but since we are heavily regulated anyway, it doesn't matter, because if you bring some efficiency, it's not terribly important because we need to meet some requirements. So that's one thing. Now, I think going forward, you might find yourself in much better position because there's definitely a move toward digitalization. Everybody's talking about digital transformation, and which will entail a whole bunch of things, but obviously will also include application of these very smart technologies. So manufacturing industry, I don't know about automotive, but I know for pharma industry, most of the big pharma companies are hiring what's called chief digital officer, who's going to be running this kind of transformation. So you have to stay plugged in, and hopefully the times going forward might be much better than what they were in the past, at least from this particular industry.
I've been called for time, so I'm going to stop. But I wanted to ask one question same question to every panelist. See, engineering as a field, and we heard Chris in the morning talking about being very responsible with engineering jobs. Engineering is a field which gives jobs to a lot of people at different levels of the community. And there is this angst about AI and automation taking over these jobs, and many of the low-hanging fruits, which we very cavalierly call, are low-hanging jobs also. So there is a real angst that if these low-hanging jobs are gone, what are these people going to do? How are we going to move them up? And what is the impact of doing extreme automation, extreme AI in engineering? So how do we address this and then think about marrying both the social relevance costs and improved productivity and improved technology in society? So I just want to get a feel for what you guys think, each of you, quickly, then we'll close the panel.
Glad you asked, because I wrote down answers for this before we came in. This was one of your question number 10, I think. See, I believe that I put in some thought and conceptualizing this, but I think that we are not so way ahead that it will eliminate the jobs. I believe the next 10 years or so, it's wrong to say such sweeping statements, but it's not very sweeping actually. The first thing is there are 3 jobs that will still remain with humans. One is new problem definers. How do you call it a problem? I don't think we are got into an age where we have recurrent networks which are goal-seeking networks that find their own problems and solve their own problems. So the problem is that you still need somebody to define problems. And that's probably the domain knowledge that people talked about. So how do I understand what problems need to be solved? Because most of the AI systems are still not AGI. They're still focused on a specific problem. The second thing is the model refiners. At least people like us have been using it to validate our view of the world and our judgment of the world. And this requires constant updation of the models. So the features that go into the models need to be constantly updated. Second, there are learnings. I recently saw the Dota 2 video about 2 months back. But you will see that the actual players were learning from the model. That happened once with us, where people felt that they were emotionally charged when they made forecasts. And then they tuned back their forecast based on the model's predictions. So they said, oh, we learned something. Let's not go out and give such a forecast. The third one is the human integration specialist. There is a need to melt these ML and AI solutions into frontliners' actual activities and processes that they can use it. Today, nobody talks about problem solving using TQM as a separate tool. It is part of the frontliner's job. And it is probably, today it is overhyped because people don't know how to run a query on a big data set or to build a prototype. But over a few years, it's going to be like Excel. So he's probably going to integrate it into his own processes and workflows and build new systems around this. So I think these 3 jobs will still remain: problem definers, model refiners, and probably human integration specialists who will work into their own systems.
I have 3 points in this. One is something related to the core AI and deep learning. There are unsolved problems. Particularly, one problem is generalization. How generalized you can create a solution which can apply to any kind of application context. Until the problem of generalization is solved to a reasonable extent, any generalized solution across manufacturing is not going to be a practicality. That in turn relates to the job losses are not going to be that high. And this will continue, this research will continue. The second point is, with the available AI technology, there is likely to be a shift of activities, just like what I had told in a typical software engineering lifecycle. Test engineering effort could be shifted to the domain expert's time or his efforts. That kind of a shift is likely to happen, but there again, complete job loss is something which needs to be taken with a pinch of salt. The third point I would like to make is, we are talking a lot about ethical aspects, safety, security, and job losses. with the current technology, but still we don't have complete data about what is the real quantum of job loss in manufacturing. I mean, there could be in IT industry or some other very specific focused industry, but overall, that number is not yet conversant with the worry about job losses per se. It could only be a shift of expertise, which happened while the computers were invented.
So very, very quickly, we have to wrap up.
Yeah, I mean, my point is that while this industry is getting completely getting automated, the predictability about the automation, I mean, either if it's a human being there, unless that gets sorted out, then the machine can come in. So to even make make a worker reliably work consistently for a very long time itself is a challenge. And understanding that, solving that problem, then moving to machines is probably has happened if you see the way the machines are getting inserted into the system. So I feel we are still little, in the short, it's not going to change, but in maybe in 10, 15 years, if you have understood the operations and we are bringing in consistency to that particular operation, which the human is doing, if that reliability gets achieved, then that's where then the automation through machine intelligence can happen. But until then, I don't think the people getting replaced. There are several examples I can give. One is the warehouse worker who is collecting putting the order items into a tote. Requires some bit of human touch to understand whether when several scenarios happen, when the item is not correct, item is damaged. You can say many things, but then it's not happening yet in the sense of human is able to make a decision, whereas machine will not be able to make that decision. Yeah.
Sorry, I thought I'll go through, but still it still takes time. So what I'm going to do is I'm going to summarize what the three panelists said. They can agree or not agree. Next 15 to 20 years, they say there's no problem. Yes? That's what the three to my right have said. So to the left, I'm going to just ask for a one-word answer, yes or no. Okay? So next 10 to 15 years, no problem. Yes or no?
I have to say yes or no. After lunch, no. Okay. Okay. No.
Yeah, it's not going to affect in the near journey.
I'm going to disagree. I think yes, with some qualifiers.
I think it's a catastrophe waiting to happen.
Okay, with that we will end the panel, and thank you very much for being here, and I hope it was useful for okay. Just 1 second. Okay. Okay, so I'll just give the panelists a moment too. There's a lunch in the AC dining hall, and it's for an hour. Please assemble back here after an hour. In the meanwhile, I'll give a memento for all our panelists, and we will end the session.
One minute, photo, just a minute for a photograph. Thank you.
Good afternoon, folks. I hope you all had a wonderful session in the morning. At least I was flitting from one round table to another, and I found very combative audience and the panelists, which I thought made for great discussions. So we So we are now getting to the second half of the panel. You would find bingo cards being distributed. So we thought, before we get into the more heavy-duty summarizations and all of that, let's have a fun AI game. So make sure you all have a bingo card.
Yeah.
There are some exciting gifts to be won if you win at bingo. I hope everybody has got one. For this bingo game, I have requested my friend Karthik Vaidyanathan to conduct the game for us. He runs a very exciting, very interesting startup called Play to Learn. And he's been working with a number of professors in IIT Madras in trying to learn engineering in a fun way. And in fact, we worked with Karthik in creating this game. So Karthik, over to you.
Thanks a lot, Krishnan. So this is just some pure fun, hopefully some lot of learning also. All of you, how many of you are familiar with bingo? Housey? It's various, okay. This is, in a typical bingo or a housey, you will find numbers. In this, it's an adapted version where you will find answers and you need to match the answers to the questions. So each of you will have 6 squares, right, of 9 cells each, right? The first thing you need to do is identify any 2 of your choice, just at random, okay? That is what will be your focus when you play the game, right? Only those 2 squares have to be earmarked. It can be any 2 of the 6. There are about 20 questions. And I'll go through the questions one by one. I'll read out the questions parallelly, the slide will be shown. Okay? As soon as you see the question, you try to find the answer in the 2 squares that you have identified in your sheet. If you find any of the answers matching, put a tick mark. And then so on, we'll keep going. The bingo wins are, if you get a top row right, top row, bottom row, left column, right column. There are no diagonals. There is no middle row and middle column counted. It's only the extremes. And the last one is, of course, the full bingo. Whoever completes the full house gets all the questions right. Okay? Is it clear? Sorry? No, I said you have to choose only 2 out of the 6 squares. The rest are not even under consideration. Within those 2 squares, if you happen to get any 1 row or 1 column, okay, you can raise your hands and there will be people going around and validating your answers. And the answers will be given then and there, right after every question, okay, so that you can immediately do a self-validation. The question will be read out and then it will be followed by the answer. And if you happen to do a row or a column, just raise your hands, and every row and every column, there will be only one declaration. Supposing somebody makes the top row, that's it. The next sign of a win will be the bottom row or a left column or a right column. Is that clear? So you can't, another person can't claim later that they have completed the top row subsequently. Okay? Okay. So let's get going. Helping me to proceed. Yeah, okay, great. We'll get started. Okay, are you able to, all of you able to see it? Let's get going. The summer workshop organized by John McCarthy and team in 1956 that launched the AI revolution. You'll get roughly about 15-20 seconds. Okay, the answer is Dartmouth College. Moving on, question 2. A class of deep neural networks most commonly applied to analyzing visual imagery. It's CNN, convolutional neural network. Question 3. This AI system refuses to open the pod bay doors in 2001: A Space Odyssey. Answer is HAL. Question 4. Email filters and smart reply in Gmail, predictive searches, and feeds that you see on your timeline are examples of AI in dash. Oh, you got something? Okay, anybody else got? Please raise your hands if you got any. You got it? Okay. Gift. Hey, can you somebody give a gift? Okay. Answer is AI for productivity and social media. Moving on, the first course on AI in India was taught at which institution? IIT Kanpur is the answer. Done? Let me just pause. Please raise your hands. 1, 2, 3.
You decide who I should go to first.
Yeah, 4. There's a 4th person here. Yeah, sorry, I just lost track. What did you get, the first person who got it? Left, he had got left.
Right column is done here.
Right column is done here, right? Okay. All right. Question 6. A class of machine learning systems where two neural networks contest with each other. Okay. Answer is generative adversarial network, GAN. You got it? You got bottom right, bottom row. What did you get? Top row. Top row and bottom row. Okay. Top row done there. Top row, 2 top rows and 1 bottom row. I think with this, we are left only with the full bingo, if I'm not mistaken. We got left done, right done, top and bottom done. So the only thing pending is the full bingo. Let's see who gets it. Huh? Any one full square is good enough. Any one of the two full squares is considered a full bingo.
How many full houses prizes do we have?
5.
Five.
5 full house prizes we have.
Not the book though.
Not the book, some different one. Okay. Okay, moving on to the next question.
You have to earn, you have to come forward and claim it.
This evil AI system tries to destroy the humanity in Terminator. The only claim going forward can be the full bingo or all the 8 answers in a square. Answer is Skynet. Question 8. A bank or telco's chatbot that answers customers' queries, responds to customer complaints are examples of AI in dash.
If you do all 20 questions, everybody gets the full house.
Okay, answer is AI for customer service. Question 9. India initiated this project, Government of India's first program on AI, in 1986 as a part of their Indian 5th Generational Computer Systems Research Program. Answer is Knowledge-Based Computing Systems, KBCS. Question 10. An area of machine learning concerned with how software agents ought to take actions in an environment so as to maximize some notion of cumulative reward.
Since Ravi is involved, there have to be one question whose answer was Ravi. Reinforcement.
Reinforcement learning is the answer. Question 11. This cute robot in Star Wars that serves Skywalker is called?
Next you can expect. Whoever runs first to the stage.
Okay, 11 questions up, I think.
Whoever gets full house has to come here to correct it.
Answer is R2D2. Question 12. Fraud detection in transactions, credit risk scoring of applicants are examples of AI in?
Check that.
Done? Looks like? Okay. लॉक किया जाए? Done? Krishnan looks like he has done. Okay, the answer for question number 12 for the benefit of all is AI for financial services. Okay, moving on. An example of an early AI project in India, Ekalavya, A knowledge-based program designed to support a community health worker was developed here. Done? Done? Krishnan, there is a claim here. Please come on to the stage. People who think they have done, please come on to the stage. We'll just validate. Oh. I don't think many people will do this. Not? Okay, the answer is IIT Madras. One more claim there. Oh, great. Big round of applause. Okay, so moving on. A type of machine learning algorithm used to draw inferences from data sets consisting of input data without labeled responses is called dash. Done? 1, 2, 3. All of you come over to the stage, near the stage. We'll.
Yeah, I should be doing all the work. Okay, he's got it.
So 2 done, 3 done. There is a 4th and a 5th claim. Let's see how the validation goes. She's got it. So 4th is taken off. And there is a 5th claimant. Done? Okay, great. Well done, all of you.
This thing, you get a book.
Huh? Yeah. 1 second. Just 1 second.
Yeah.
Krishnan, probably should we go on or?
No, we're done.
We are done. I'll just
give the answers.
Yeah.
Quickly.
Okay, quickly I'll give the answers for the rest. So question 14, the answer is unsupervised learning. Question 15, just take a half a minute to read it. Researchers at Princeton start to assemble this large database to aid in visual object recognition. The database is called, any answers? Just ImageNet. Yes, that's right. Smart factories, prediction of failure of machines, and preventive maintenance are examples of AI in engineering. Yes. An example of an early AI project in India, flight scheduling expert system. Anybody? CDAC Mumbai. Yes. A type of ML algorithm that infers a function from labeled training data and maps an input to the output. Yes, that's right. 2016 this Google system, AlphaGo. AI for detecting cancers, blood smears, etc. AI for healthcare. That's it. We are done. Good work, everyone.
Great. This is yours.
Yeah. Hope you all had fun. Get ready for the bigger sessions now, deeper sessions.
Thank you, Karthik. We will now, in the lead up to this colloquium, Itihasa had published a landscape of AI research in India. Today we had 3 roundtables in parallel on different aspects of AI. Our next session will present a summary of the learnings that we got today. I invite the following people onto the stage. Dr. Daya Sindhu, my partner and co-founder of Itihasa Research and Digital. Professor Raghunathan Rangaswamy, professor at IIT Madras, an anchor for AI in engineering. Dr. Harish Guru Prasad. Dr. Harish? Ah, yes, please. Anchor for AI and ethics, fairness, and explainability. Dr. Pratyush Panda and Dr. Mitesh Kapta. He's not yet here. Okay. They were the anchors for AI for the next billion users in India. Now, what we plan to do is we plan to go in this, in this particular order. And of course, I need to get my laptop and plug it in. 10 minutes each, followed by Q&A from the audience.
Thank you. So let me first give you a background of the research that Itihasa did on the landscape of AI/ML research in India. Right. So the objective was very simple. It was just to see where we are as a country in terms of our capability in research in this emerging domain. And the interest was twofold. One, AI/ML has tremendous impact on Indian citizens. For example, the transformative technology that it is, I think some of you would have experienced the kind of applications that AI/ML has. And this was one of the driving reasons why we felt that we should understand what we are doing in the country today. And the second one are the socio-cultural implications. For example, some of the translation abilities that machine learning provides. For example, you might right now not watch a movie in a language which is not your mother tongue or Hindi or English. But imagine if the entire repertoire of movies and regional language is open to you, and you don't have to wait for somebody to subtitle it in your language, right? So it kind of gets citizens together. So those are two really powerful aspects of AI/ML technology. The next is in terms of the industry. So again, most of you would have heard during the morning deliberations that there is this transformative ability that comes along with AI/ML technologies, and these are the disruptive technologies that are powering industries and helping them become more, let's say, efficient and doing things which they were not able to do a few years ago, right? So that's one. And the next one is very close to India. So in the morning, Chris was mentioning about 4 million people being employed in the Indian IT services industry, right? So there are some reports which say that there might be a disruption of jobs in this industry. And this has been the single largest creator of jobs for college-educated youth coming out of India in the past 20 years. So what happens if there is a slowdown in this industry? There are going to be a lot more folks who are college-educated with reasonably good professional qualifications, probably not finding a job easily, right? So we need to see how this AI/ML is going to impact the IT services industry. So we decided to look at the indigenous R&D, which is really the heart of building a capability for India in the next 5 to 10 years. So let's look at some of those interesting takeaways. So the good thing is that most of the experts, the researchers that we interviewed felt that there's not going to be large-scale disruption of jobs because of AI/ML. So the opinion was that AI/ML is going to help the specialists who are doing their job. So a classic statement that captures it is that it's not going to replace a radiologist, but it's going to replace a radiologist who's not going to use AI/ML, right? And the only domain where there's likely to be some impact are those jobs which are creating label data. So if there is a job that's creating label data, then that's likely to be replaced by an AI/ML system. So the second aspect is that we can be proud that our researchers in institutions like IIT Madras and the other IITs and IISc are working on very India-specific research problems. So some of the interesting projects include prediction of monsoon, right, and modeling floods. We know the kind of destructions the vagaries and weather cause in our country. So these are some of the typical India contextual problems that are being attacked by our research. We talked about Indian language processing. So we had Professor Pushpak Bhattacharya here. So he's one of the leading lights. And another interesting research project that's been done is modeling Indian road conditions. So we all hear about companies in the US trying to come up with autonomous systems, and then how they're how they have a database of road conditions in the US and probably other developed countries. But what we also realized is that these are relatively meaningless to be used in India. Our conditions are unique, and we feel that we need to use India-related data to do this. And finally, in terms of the size of the research ecosystem that we have, there are about 50 to 75 PIs in AI in India. And we are publishing the third highest number of citable research documents in this domain. So what are the recommendations from our study? The first is straightforward. It probably cuts across multiple other technology domains and science domains in India, is that we need to increase the number of PhD students for AI research. And since this is a very hot area, we are losing our good students to universities abroad and to industry. So maybe create some very specific initiatives that can attract some of these students to pursue research in Indian institutions. So just to give a comparison of what China is doing, they have a program which by 2020 is going to ensure that there are 500 teachers and 5,000 students who are going to be AI experts. And this is going to be, every year China is going to produce 5,000 students who are going to be, from 2020 onwards, who are going to be having a deep expertise in AI. So the second recommendation is in terms of enhancing the compute infrastructure in our research institutes. So one is to obviously buy the GPUs and the TPUs that are there today, and we are in some sense underpowered in terms of computing infra. So we need to address this as an immediate priority problem. So one of the interesting aspects that we realized was that we can use some of the work being done in IIT Madras by the RISE group in terms of developing open sourced SOCs and see how they can power some of the compute infra for AI ML for India. So it's going to be much cheaper, and it's going to be an Indian hardware. So that's going to be interesting. Then the third recommendation is in terms of setting a center of excellence. A very good example is the RBC DESI, and the idea is to just not to have computer scientists, but also have a multidisciplinary set of faculty members, researchers from allied domains, the application areas, and of course, researchers from the humanities side to understand the aspects of how the AI system interacts with the users. So now I'll hand it over to Krishna to take you through the rest of the recommendations. Thank you.
And in the interest of time, I'll just move forward very quickly. There are 3 more recommendations. I strongly recommend you download the report and read them in greater detail. But the next 3 are basically creating data sets for India. And hopefully we'll see some announcements later as well. The couple of examples we gave. There's one on Indian languages, there's one on driving conditions in India, but there's a very important aspect that we need to consider. One other approach, while there is a COE approach, some others suggested adopting a grand challenges approach, like DARPA, and how, for example, the whole autonomous vehicle came out of a grand challenge. What could be those grand challenges? In fact, Professor Kamakoti headed a task force, identified some 4 or 5 such grand challenges. This could be another approach. And the final one was in linking these institutional mechanisms of the COEs and grand challenges to a startup ecosystem. And we are beginning to see some of those aspects, the IIT Madras Incubation Cell, the SIGN and IIT Bombay. In fact, some of the professors here on the panel are examples of people who have taken their research and gone to startups. So I think we are beginning to see some green shoots here. Thank you. I'll now request Professor Raghu to present his piece.
Okay, so we have not lost too many people, looks like, till 1:30. So I anchored a session on AI in engineering. Actually, it was interesting when there was this morning conversation between Ravi and Chris. And Ravi was going through each of these sessions, and he said, what about AI in engineering? Immediately, Chris, at least to me, it looked like, not really needed. So I was a little worried about most of the people leaving the panel at that time. So I guess the interpretation is one has to be responsible and develop techniques which have relevance and use in the current social context. In any case, we had panelists from several engineering organizations who are also practitioners of data science AI in their organization, so that we could get a rich overview of what their thoughts are in terms of AI in engineering. So after all the deliberations, I have put together about 3 slides here, which summarizes what we discussed and talked about. Of course, I think if you personally ask me, I would say application of AI in engineering in India, and I'm not sure, I would say even globally also, is still in a very nascent stage. I don't think there are very many systems which are reliably working without supervision. I'll contrast, for example, something that all of us know, a PID controller, right? If you think of how many systems use PID controllers, you can think of millions and millions of them. They are working repeatedly, without errors, for years, without anyone doing anything. That's when you would say we have systems that are working successfully. If you were to put such a benchmark on any AI application in engineering, I would say that we'll have almost nothing in terms of applications. So the question of reliability in engineering and the question of simplicity of use are 2 important things that I think we should think about. So in that sense, I would say AI applications, which are widespread in engineering, are not many. However, there's a lot of interest. Of course, there's a lot of buzz, and I also mentioned this in the morning. We said AI is new, AI is not new, and you would have seen that in the quiz that was conducted. In fact, even in chemical engineering, I was mentioning, the very first workshop on AI in process engineering, you know which year it was conducted in? People who are here in this room would know. It was 1987, conducted at MIT. So this is not a new topic, but because of the technological improvements in communication, data storage cost, and compute power, you're seeing a lot more excitement in this. However, from an Indian context, and this I can say both as an academic who sat in the panel and have been reading stuff, and also as a practitioner who is a founder of a data analytics startup, I will say India is still very far from getting these solutions in place because data is still not easily available. So there's a lot of push for digitalization of data, which people talk about. Typically, people think when you say I have data, you have lots of people who come and tell you they have tons of data. But if you were to just use a qualifier, usable, the amount of data you have becomes very less, simply because this data is in disparate systems, they are in silos, they are not integrated together, so you cannot run an algorithm on all of this. So we believe standardization of data and digitalization of data that breaks down silos. So when I mean silos, you might have an ERP system, you might have a PLC system, you have a DCS, and all of this data will have to come into the same repository. Otherwise, there's no point in saying I will build systems which will do better than before, because there are systems which use DCS data and get the maximum out of the data now. There are systems which use ERP, right? It's not as if these systems don't exist. The power of big data and data science and AI comes only when you put all of these together and you're able to take advantage of it. So that is really missing in terms of engineering organizations. Of course, from an engineering viewpoint, it's very, very important that you have repeatable and interpretable results. In fact, it's not only engineering where interpretable results are important. As I just learned, we have been doing this project for ESPN Cricinfo for the past 2.5 months. And interpretability of results there seem to be even more important than engineering. So for example, if you have a system which says, okay, this is what will happen, and if you're not able to explain why the system is telling you this is happening or this is going to happen, there is no value. Instead, if you said, Dhoni always hits in the last few overs, we know he can hit 26 runs, and that's what the algorithm has picked up somehow. If that interpretability you give, only then people are willing to use the system, right? So interpretability and ability to communicate the results of the system in a manner in which a domain expert feels comfortable with is one of the most important aspects of any AI solution you have. And again, doing this repeatably and interpretable format, I don't think exists yet. So these are all opportunity areas for researchers in AI working in engineering systems to look at. In terms of algorithms, one of the questions that always comes about is, are there such fantastic new algorithms that are coming out? Or these are tweaks to existing algorithms that we have all seen before? So my feeling is it's somewhere in the middle. There are some new things that are coming up. But most of these that we talk about right now, we have seen before. We have seen neural networks before. We have seen all kinds of graph networks before and so on. It is the compute power and the other technology advancements which are improving these. So in that sense, there is a real question of what new algorithms do you need? Particularly if you think about application of these algorithms in industry, are there industries which are waiting to get new algorithms, right? I would say not yet, right? Because we have not even crossed the basic barrier. So the bigger challenge, I think, is not in new algorithm development. The bigger challenge is in really figuring out how you would integrate domain knowledge into this and get interpretable results. So those are the bigger challenges in terms of AI algorithms from implementation viewpoint. And there was an interesting point one of the panelists made where he said, you think about some simple computations you want to do, you will quickly do that in Excel and then get some idea that will work. And then you say, I'm going to, based on this, I'll develop an algorithm which will be implemented and so on. So is there an equivalent for AI where I have a benchtop setup where I quickly run my algorithm and say there's some POC which can be done and I can use it for this. So that is a takeaway. Of course, again, we come back to how we capture domain knowledge, how do we capture expertise of people who are retiring so that we can build better and better systems is another important thing. Of course, we have talked about democratization of data, ML, AI. How do you make sure that AI, ML, and all of these technologies are available to a wide cross-section of the population? That's another important question to answer. Of course, the last bit was about the same questions that we have been asking. Is there a problem in terms of jobs because of AI? Are jobs going to vanish? Majority of our panel felt that this was not a problem. And some said things are not yet quantified. Some felt AI is not proven to be reliable, that you can simply get rid of people. And some people said it might be that the job focus will go from one to another. Jobs won't be lost. But there is a problem here. I think there is a real problem in the sense that we have to face facts. Not everyone can do algorithms, right? As long as the shift is going up and up an intellectual scale, if I may say, then there is a real problem, right? Because there are still lower level jobs that people will have to do. If all of those are automated, then how do you skill them to be really strong at the algorithmic level? It's a really difficult question to answer. Of course, the final point is there is a lot of angst that India-specific data sets are not there. Companies are hoarding data. They are not showing their data. And of course, the answer from the companies is that we don't know what we have in the data. We might have gold there. Why would I give it to you? I might have IP. I was telling someone, it's like having a box which is locked. You don't have the key to it. You don't know what is inside. It could just be all rocks, or it could just be all gold. Okay, how would you give this box away, right? So you'll hold the box till you find the key and find out what it is. So that's kind of a catch situation that needs to be addressed. So these are the main takeaways from our panel on AI and engineering. And if there are any questions after this, I'll be happy to answer. Thank you.
a second and then.
And I think the same question. Okay, I think the question was that this job loss and lack of data sets and so on, is it unique to AI or other technologies should have also, to engineering, sorry, unique to engineering or other technologies should have also, yeah. So I think I'll answer the two parts. The second part I think is a little unique to AI in the sense that the focus on data sets and data is a lot more than before, right? You don't. Oh, no. There is no difference. There is no difference. Okay. So if you are talking about AI in healthcare, same problems exist, I assume. But AI in engineering from a job perspective is slightly different, I still think, right? Because manufacturing jobs and many of the jobs in the factories, which is an engine for growth and which is an engine for livelihood for lots of people who are unskilled, right? If you hit that section, and you might say, look, these jobs will become better jobs, right? But unfortunately, it might not be a political thing to say, but unfortunately, not everyone can be scaled up to a certain skill level. So when that happens, how do you take care of people who are left out? Is an important and really relevant question that all of us should think about.
So I think we can have one more question when they said anything.
In automobile industries, anyway, it is moving towards electric cars, where you will not need engine, differential gearbox. So almost 40 to 50, 60% of jobs are going to go irrespective of AI. So I think there is going to be a big shift in the, especially auto and tier 1 sector, more because of the electric technology rather than AI, I would say.
Why would you say electric technology than AI?
Because you see, the number of components that goes into electric car will be very minimal. So you will do away with the engine walls, gearbox. Most of the heavy duty where the labor is employed will not be there. So I think there is a general feeling not only the OE, but even the tier 1 companies, most of the 40 to 50% of the jobs are likely to go.
Okay, we will take this up.
Okay. Hello, everyone. Okay. Yes, mic works. Yeah. So I was anchor for the panel on AI ethics, fairness, and explainability, and it was a broad-ranging discussion and it was very interesting. So for those who are not there, I'll just define what these terms really mean. So in the context of ethics, I mean, where do ethics questions occur in AI? I mean, they occur left, right, and center throughout. So for example, in my opinion, the place that directly the ethics impacts is, for example, in say self-driving cars. So you might actually be writing a piece of code which takes in, like say, whether there is a pedestrian in front of you and whether there is a vehicle behind you, and you might have to say something, right? I mean, take left, take right, go straight, you have to say something. And that is essentially the trolley problem in ethics. That's the fundamental, I mean, there is no real solution to that, but point is, when you are driving a car, you don't need to solve the problem to drive the car. But when you are writing an AI code for self-driving systems, you have to write a piece of code which solves that. I mean, whether that piece of code will ever come into action or not, you'll have to still write that. So that means that you are essentially solving ethics problems left, right, and center, and that's not escapable. And other than that, there are other places where ethics makes an appearance. For example, say data misuse by, say, Facebook or Cambridge Analytica or, say, NSA, or there is these so many issues which only make sense with with AI. Without AI, I mean, you can collect data of 6 billion people, but without AI, there's no way you can use it. So you don't mind probably giving the data away. But with AI, these problems become a real issue. So how do you handle such data in an ethical way so that no one is hurt, so that's the central point of ethics in AI. The second point, which is fairness, comes into play mainly because the main purpose of an AI system is to say give welfare to say its users or the citizens of the world in general. What generally happens is it might benefit one section of the society more than the other. So that's really the essence of the fairness problem. How do you design systems which benefits everyone at least more or less equally, right? This happens, once again, very often because of biases in the data. For example, if you have people gathering data, they might just gather data from, say, men or from the affluent society, and they might not gather data from all parts of the society, and which means that your recommendations are going to be inherently biased in favor of the people whom you gather data from. So how do you correct for this kind of problem? So that's the fairness aspect of it. And yeah, that's the fairness aspect of it. And the third part, which was the explainability, and it's not really a problem, it's really it's a feature, desired feature to have. For example, the example that I gave in the panel was that of, say, complicated AI systems, which are really not easily interpretable at all. You have complicated software systems already. For example, you have the Linux system, which is million lines of code. No one can really interpret that immediately, but it is possible to inspect sections by sections because of the modularity. But the AI systems currently are really just functions which take in a bunch of numbers and output a bunch of numbers. In such a scenario, there is, how do you debug such a system? So it is just not possible to debug such a system, and that is one of the main reasons why we need explainable numbers. We don't, for example, as Raghu also mentioned, if you just have a black box which has 100% accuracy but gives completely meaningless numbers, you input a bunch of numbers and it outputs another bunch of numbers, it might be 100% accurate, but you'll never ever use it because finally there must be a human at the end of it who uses it. For example, you might have a system which can predict with 100% accuracy whether a person has, say, cancer or not, but no one's going to use that because the doctor has to believe in the system first before he will recommend the result of that to the patient. So that's the other aspect. So how do you build explainable AI systems? And in a way, explainable systems will mitigate the risk of bias and fairness to a certain extent. So if you understand why something is happening, say, for example, if a system says, I'm going to reject this loan because this person is black, and if that's what the system really says, you can really step in and say, well, that's not a good thing to do. Bad AI. You can beat the AI and condition it for like you do a dog. That's something which you can do. But if it doesn't, it just says, okay, this is the feature vector and this is the result. There is no way you can correct for it. So that's the broad themes behind this panel. And this is really not an immediate problem right now in India. I will say that because this is mostly a problem in the developed world, mainly because very advanced systems of AI are not in use. For example, AI in healthcare is not really used very well. I mean, in fact, one of the panelists said healthcare is not, it's just bad healthcare. Forget about having good AI in healthcare. We don't really even have healthcare. So in such a situation, it's probably not that big of an issue. But really, it takes a matter of maybe a few years to reach a stage where AI is pervasive in every walk of life. In such cases, bias and fairness and ethics are really concerns which should be put center. It should be front and center and not something which should be fixed after the problems are caused. Right? I mean, it might be too late to fix it after the problems are caused, and that's the reason why we need to analyze these now. Right? So we had in the panel, we had a wide-ranging discussion. We had discussions on say, for example, we had discussions on how to summarize videos, right? I mean, how, for example, there's this, you have a video summarizing platform. How do you summarize video? When you are summarizing that, what if you come across a video which is, say, propagating hate speech or propaganda, which you know to be, or saying some facts which you know to be patently false? So, you are maybe a private organization. Do you censor free speech here, or do you say, okay, this is, it's fine, I'm not going to censor free speech, I'm just going to allow it? Or do you say, I'm going to censor free speech here and say, this is not right? So these are different points of the benefit risk trade-off here, and it's not an easy decision to make either way, but this is a decision that must be made at some point, right?
So, and there was also talk on how data collection, the fundamental resource of AI is data. And well, bias algorithms, one of the main reasons for the bias algorithms is biased data. And how do you handle bias? In the standard legal framework for handling biased data is through what is called consent, creep, and confidentiality. So the consent means that the user who gives the data is aware of that he is giving the data, is aware that he or she is really knows what the data will be used for, aware that who will use that data, aware that what the impact of the data will be, and ideally should be able to, say, take back the data, or ideally should be able to, so that's the kind of situation that we should be in for data. And the creep part of it essentially is that you might start a project, for example, with, say, with the focus on welfare, but it might creep onto other things like security and so on. So, and under such situations, what do we do for that? And confidentiality is, I mean, obviously you want the data to remain, you might be okay with making group level inferences, but not individual inferences. And there are other impacts, other discussions on finance. For example, how to make the AI for finance really inclusive to all people. And one particular question that was discussed was on giving loans, and well, the prevalent things of what all features can you use for giving out loans. For example, one thing that was discussed was, can you use the address of the person who is applying for the loan as a feature? And there might be a pretty good increase in accuracy, but is that a valid way? Is that a fair way of doing it? And those were the kind of questions that were discussed. And in the aspect of AI assistants, one question that once again comes up naturally is, well, are AI assistants always good? I mean, the first question is it always listening to us? Well, it might be, it might not be. It essentially is based on the wake word systems. The more interesting question is, does it work for everyone, right? I mean, mainly because of data bias, again, it might not work for, say, women or minorities as well as, say, it works for the majority here. And it does happen to be the truth, and there are people who are trying to mitigate these effects. And so one aspect that came about in how is, say, AI used in healthcare here in India, one comment that was made is that in healthcare, say in the West, is really sick care. Essentially, you fall sick and you take care of the sick. So that is really not, say, possible in India. I mean, it's not possible even in the US with its immense GDP. It spends 1/6 of its GDP on healthcare, and it's still not sufficient. And if we use that much money on sick care, India is just not going to make it. So the proposals were essentially on preventative care and healthcare, and not really sick care. So those, how do you use AI for those kind of things? For example, say fitness trackers and diet trackers and those kind of things were really the focus things too. And that was about it. Yeah, that's it. So any other questions? Let's wrap up.
Are you planning to take question, or you'll take it at the end?
No, we'll take it later.
Okay.
So hi, good afternoon. I'm Pratyush and Mitesh. We were co-chairing the last session that is on in AI for the next billion users in India. So AI for NBU in India. I think NBU is now a popular term that is going around. So what I'll do is slightly in a different format. I'll just simply try to rerun the panel for you, because I think most of the panelists said excellent things. I would just like to quote them. Just done a bit of abstraction thanks to the help of students who helped take notes during the meeting. So I think we started off firstly doing some level setting. We defined what is AI. So we defined AI as any non-biological entity exhibiting complex goal-oriented behavior. And we said we'll focus on the here and now of the AI. So what exactly are already possible today, and how do we translate that to applications to solve real-world problems? So we were not interested in figuring out what happens in 5 or 10 years' time. That was one tagline, here and now of AI. The second was contextualizing AI for India. So we said we have a variety of conditions in India, like large population, disparity in income, variety of languages, and so on. So how do we contextualize existing solutions for the Indian setting? Then we had a third one on ecosystem, we said that there are a variety of players involved. Academia is one of them. We are here in IIT Madras. But startups, non-for-profits, industry R&D, accelerators, and maybe even think tanks. I think Itihasa is probably here as a think tank. So all of these players have a role to play in this ecosystem. So how do we go about providing energy to this entire ecosystem and sharing information between these silos? And the final thing was doing it at scale. So building capacity at scale. How do we upskill people at scale at variety of levels? I think Chris mentioned this. Not only the CEOs of companies, the practitioners of machine learning, but also general public need to be sensitized to what AI really is, and then hence contribute to this wider adoption. So this was the initial setting, and then we went through a panel discussion. So what I'll do now is I'll just maybe say one thing that every panelist said, and then go into final 2 questions that we discussed. So Anandan from Wadhwani AI, so he showed interestingly at the very beginning a picture of someone trying to weigh a newborn baby. So it turns out weighing a newborn baby is the first thing that you do medically and enter that data, but that is already very challenging because the equipment is not good, maybe the person is not trained and so on. So he showed a solution whereby you can take a photograph of a newborn baby and estimate thereby the weight, because you can get a sense of the volume, right? So here it mentioned the point that the delivering within a context is important. So I had said initially that we need to contextualize AI to India, but he flipped that around and said we are within a context, and how do we work within that context and actually deliver a solution there? That was his focus. Then we had Pushpak Bhattacharya, director of IIT Patna. Yes, I mentioned it as IIT Pune at that time, and even now forget about it. He's of course a proponent in natural language processing. He used this nice phrase I felt, which is that India is language rich but resource scarce, right? So we have a variety of languages. He talked about some nice word plays between different languages. I think you say I laugh and stand in Bengali, and maybe in Hindi we say you laugh and fall down. So why is it other way around? Has ke gir gaya.
Has pada. Okay, yeah.
Okay, so you fall down and in Hindi, but you somehow rise in Bengali. So why do we have that, and what kinds of different challenges that has? Then he talked about Nidhi Ayog's interesting endeavor. Now he talked about the Bharat Bhasha stack, whereby lots of startups and companies can come and use things that the academia has been developing in India on NLP. Then we had Gargi from IBM. She talked interestingly about expectations with AI. She talked about how Jeopardy came in 2012 and it won a particular competition online on the TV, but people thought that we have already solved AI. So there is this human expectation around what AI is, and that can have certain consequences. I think IBM is facing a bit of that as to what really Watson can do and can't do. So I think she touched upon that. Then we had Lakshmi Prasad, who is a serial entrepreneur. He's actually an alumni from our institute. He talked about the last mile visibility. So he said that in India, the last mile data is both complex and compromised. So he said we do not have, for instance, if you talk about interlinking of rivers, it's an important policy decision that we need to make. Do we need to interlink our rivers? But it turns out that there is no good data available on the benefits or ill effects of this, right? So he talked about how he's doing some interesting work in Andhra Pradesh, where they are using sensors to estimate the groundwater quality, and also using remote sensing to do the same thing. Then we had Santosh Mishra. He's actually from the government of Tamil Nadu. He leads their e-governance agency, and he actually gave us maybe 10 problems. He said, we have these 10 problems in e-governance in Tamil Nadu. If you want, just join us and try to solve them. So he, in fact, gave a series of these problems. And anybody looking for problems in AI, please contact him. He also, interestingly, gave a framework. He is doing research also. So he talked about a framework whereby if I have a new AI problem to solve in the e-governance space, or the government is looking to solve an AI problem, what is the framework I should put in place to assess if the solution is good? So he talked about a variety of things. I'll not go through them, but he has thought through that. Then we had Sasi Sekhar from NanoPix, entrepreneur. He's interestingly doing work where they are using AI to what he called value retention in agriculture. So in agriculture, he's into the cashew post-processing market, where you need to typically segregate low-quality cashews from high-quality cashews. And he showed how they built indigenously a small machine to do that, and that was used to capture value for the farmers. So the interesting term he used was, there is demand at the bottom. It's about figuring out where the demand is and making solutions for that, right? Then Varun from Google, he talked about designing for users without digital footprints. So he talked about how Google is trying to always customize their products for users, but there is a large population in India who doesn't have a digital footprint. So how do you go about customizing things for them? He gave an interesting example where typically in India, at least in low-income houses, you would share the same device. Maybe 4 people are seeing YouTube on the same device. So how do you build profiles for all of them, and how do you still personalize things? Finally, we had Pratik from Microsoft Research. He talked about Edge ML, whereby you try to democratize the hardware for AI. So we know a lot about democratizing the software, but how do you take the hardware and make it also low cost? He talked about using decision trees on microcontrollers, having 1,000th of the power of a typical CPU, let alone a GPU. So those are the panel discussions that we had. Do you want to look at the question?
So then at the end, right, once every speaker had something to say about specific questions asked to them, we also had this open session where we asked them some pointed questions. And one of the things that we were asking, like in India, we have these 3 to 4 areas where AI, everyone is talking about using AI for agriculture. So I'd call that food, water, healthcare, and even for languages, right? Now, in all of these things, the challenges have been around for many years, right? We have always been scarce in terms of resources in each of these verticals. So why is it that now we are talking about that with much more eagerness? What was happening 10 years back, right? Were we a bit slow in reacting to the needs in these areas? If so, what was the problem in the ecosystem which led to this, right? So as Pratyush was mentioning earlier, there were many players in the ecosystem, starting from government to academia to industry and so on. So we asked them, why were we not being able to do it 10 years back, right? And a few interesting answers came from them. So one of them was this, anything that you want to do with AI, right? It's very different in terms of the business model, right? So now if you want to build something for the farmer, as you said, a very specific requirement, which is to segregate different qualities of cashew, right? Now, how do you do this at scale? How do you figure out whether this is profitable for you or not? How do you figure out whether this particular section of the demographic is actually going to adopt this or not, right? You cannot do a generic study and say, okay, people are ready for AI in India. You have to do it sector-wise, population-wise, different region-wise, and so on, right? And all of this is very infeasible in a large and diverse country like India. So these challenges, this particular challenge, right, it's still existent, but we are going to tackle it as we go along, right? So the other important point which came up, why AI has not been kind of almost omnipresent in India as it is in some other countries, is that the challenge of data, right? And I think Raghu made this point that everyone says we have a lot of data, but the key thing here is usable data, right? We don't really have usable data. We don't really have usable data in the languages that we care about, right? So that's another important factor. Something as simple as building a chatbot for a farmer in rural areas of Tamil Nadu where the dialect may also be different. How do you go about collecting data for that, right? It's very, very hard to do that, right? So these are some of the important points that came up. And a follow-up question on this was, right, so now given that these challenges exist, can we actually think of a platform where we do everything, right, from sourcing problems, right? So as you said, there was this representative from government, IAS officer, who on the spot gave us 10 problems, right? There are problems waiting to be solved from all sections of the society. Can we have a platform where we source these problems, have a labeling mechanism, data collection mechanism, have a problem-solving mechanism, right? All of this in an open source framework where all of us, say the academicians and the industry get together, define a problem, say how to solve it, right? Just give the outline for this is how you need to approach it. You need to use this tool from here, that paper is what you need to read, this data is what you need to collect. And in a crowdsourced, open source manner, can we attack problems which are relevant for the country, right? These are not problems inspired from the West, but say inspired from our farmers, our doctors, our nurses, and so on, right? So that was an important kind of an outcome where we ended, that something like that is really the need of the hour, and we should all get together to do something of that sort.
Thank you.
Thank you, everyone. I think in the interest of time, I know that there will be questions. In the interest of time, we are going to have a tea break later. And my request is at that point of time, please do interact with them. In fact, there will be other opportunities to interact with this community, which is what our next session is going to be talking about. But before that, we'll want to give the mementos to the anchors who did a splendid job today. Big hand to them. I'll also request Mr. Sridhar, the COO of RB Desai, to come and hand over the mementos. Now for the, one of the things we decided at the beginning of this, when we designed this colloquium, is not to leave this colloquium as just a one-day event, and then we forget about it until the next colloquium we attend. So we did want to do something where we announce some way of interaction which goes beyond this day. And that is what we'll have in the next session, where I will invite Professor Ravindran to come and talk about some important announcements to be made at this colloquium.